Welcome to a tutorial on the 8085 jump instructions. Okay, now the jump instructions in the 8085 microprocessor can be divided into two broad categories. Okay, namely the unconditional jump instructions, and obviously there's the other one that's the conditional. Okay, so now in the unconditional jump instruction, where they just include, it just includes only one instruction, that is JMP. Okay, now you can basically use this instruction to jump or transfer the program control to any given memory location. Okay, so you just need to provide a 16-bit memory address over here. Okay, so I'm just gonna write that down. There you go. Now this 16-bit memory address, which is just actually what serves as the operand of this particular jump instruction, that's the unconditional one. Okay, so what it's basically used for is to jump into the corresponding, or rather specified, memory address where you have written down a specific set of codes which is supposed to be executed whenever you want to jump into that particular memory address. Okay, and that's the unconditional one. And speaking about the conditional jump instructions, they just include these following 8 conditions, 8 instructions, okay, that basically will operate under certain specific conditions of the flag bits concerned. Like for example, the top 2 instructions, that's the JC and JNC, but this stands for basically jump on carry and jump on no carry. So they will operate based on whether the carry flag bit is either a 1 or a 0. Okay, next, the JZ and the JNZ, standing for jump on 0 and jump on no 0 instructions, they operate under the condition of the 0 flag, whether it's a 1 or a 0. Similarly, we have the rest of the 4 instructions, the talking about the JP and JM, where they operate on based on the sign flag condition, whether it's a 0 or a 1. Okay, or the last 2, that's jump on even parity, that's JPE, and jump on odd parity, that's JPO. Now they're operated based on the condition of the parity bit, okay, of the flag registers, whether it's just a 1 or a 0. Okay, now these are basically the 2 broad categories of jump instructions that are included in the 8085 instruction set. Okay, let's just explore them in detail. So we're going to start with the unconditional jump instruction over here, that is JMP, and as its operand, as I said, it includes a specified 16-bit memory address where you're supposed to transfer the program control. So what the jump instructions basically do is that what they help in transferring the program control to a different memory location or memory address. Okay, so in short, the JMP instruction will transfer program control to the specified memory address while serving as the operand. Okay, so whenever a jump instruction is encountered in a program, the program counter gets loaded with this specified 16-bit memory address. Okay, and then immediately the program control gets transferred over there. So as a description, I might write over here, let's just give an example. Like for example, if you'd write over here, like say for example with jump 2050H, okay, then what would the program, or rather what the 8085 would do is that it'll just transfer the program control to this particular memory location. Let's say you had some sort of programming code written at the 2050H memory location, which would just perform some sort of pre-designated operation, okay, in your program, as the case may be. You'd often require jump statements whenever writing complex programs. So over there, it's the JMP instruction is a very simple means of executing some sort of an instruction present at the specified memory location. Okay, like say for example, you want to these instructions were basically used for creating counter type programs, or making loops and all. So if I might give you a simple programming code, Okay, so here we have one. So you can see that, well, in these two lines of code that I've just written here as an example. So this is basically an example that I'm just showing over here. So in this example, you can see that, well, we have an in instruction, okay, at the memory location 2000H, okay, and next in the corresponding I mean in the subsequent memory location 2001H, okay, we have this jump instruction JMP. That's the unconditional jump, okay, and it's basically instructing the 8085 microprocessor to jump into the location 2000H, okay, where the in instruction is basically present. Okay, so what it'll basically do is that, well, it would fetch an input code, okay, an 8-bit input code from a designated port address. So this particular thing is over here is basically a port address, okay, and this port address, I mean this particular input code will fetch from this particular XXH, that's the port address given over here, but continue to happen, okay, as long as the program keeps on running inside the 8085 microprocessor. So every time this input code from the XXH port address gets loaded into the accumulator, okay, and then you can basically the program code jumps to the location 2001H, and the program controller transfers there, and then again you encounter the jump instruction and again go over there. So this entire cycle keeps repeating on and on. So every time you're just fetching the input code from the port address and sending it to the accumulator. Okay, so this is what is happening over here in this particular example. So likewise, you can just set up loops and counters using such kind of jump instructions whenever and wherever you might require in your program. And lastly, this particular unconditional jump instruction is basically a 3-byte instruction, okay, with 1 byte serving for the JMP command, okay, and the other 2 bytes for the upper and the lower 8 bits of the 16-bit memory address that you're specifying over here as the operand of this particular instruction. Okay, and also the flag bits, okay, they remain unaffected by the jump instruction. Okay, so now that we have covered the unconditional jump instruction, let's just take a look at the conditional ones. Okay, so here we are, and now we're starting the conditional jump instructions with the JC and the JNC instructions. Okay, now the JC instruction actually stands for jump on carry, okay, where the it's a conditional jump instruction, as you'll know. And now in this particular jump instruction, well, the condition is just set by whether the carry flag is set or not. Okay, now if the carry flag bit is basically was set, okay, that is if the carry flag is equal to a logic level 1, okay, then only this instruction would get executed and the program control would transfer to the specified 16-bit memory address. Okay, and on the contrary, the JNC instruction, but it just stands for jump on no carry, which means that, well, the particular jump instruction, let's see, JNC, would get executed only if the carry flag bit is reset, that it is basically set to the logic level 0. Okay, and only then the program control would transfer to the specified 16-bit memory location. All right, now their use completely depends upon the will of the programmer and how he's designing the program. Okay, but as a guide, you might consider taking these examples into account. Now let's say in this particular example, we've loaded the accumulator with the data byte FFH, okay, and the register B, where it contains the data byte 02H. Now we're supposed to add them. Now we've just written a short program to just add them up. Okay. Now after we add them, let's say we're supposed to monitor whether there is a carry or not. Okay. So what do? We also need to load the register C with a data byte of 00H, which is supposed to record the carry. So we also write down a code, let's say okay, MVI, let's say after this we just write in the code, okay, MVI C comma 00H, not a problem. Okay, and now we're supposed to monitor for the carry. So how can we do that? Well, here we can use either one of these instructions, okay, but using the JNC is much more preferable, as this just makes the the programming code shorter in length. Okay, so if you use the jump on carry, that's a JC command, on the other hand, then you need to maybe add a few more jump instructions, or maybe your program code would just get a little longer. So in this case we'd prefer using JNC. Alright, so we can just do it this way. So we are gonna write here about JNC, okay, so the jump on no carry to, let's say, a certain memory location, let's say XXXXH, okay, and we don't know where it is, and then we can just write down the following codes over here. Now we are supposed to increment the value of the register C if there is a carry, so we're gonna write here INRC, okay, and then finally STA. Let's say we need to store the result, okay, so we just store the result in let's say a memory location. Okay, we can just do it this way, so let this be XX0, or let's just change the memory location over here. Let's just keep it as well XX01H, okay, and let's just keep this one as well, let's say okay, XX what could it be? Well, let's say XX32H. Okay, that's better. So in this particular code over here, what will happen is that, well, if there is no carry, the instruction code, I mean the program control code, would just jump directly into storing the result in the accumulator. So this is where the XX01 location should be. So if we are using jump instructions, then we need to keep a track of where we're supposed to transfer the program control, okay, depending upon how we are actually designing the program. So this was just an example of how to use such a kind of jump instruction depending upon whether the carry flag is set or not. Now we know that whenever we would add data bytes such as FFH and 02H, there would be a carry. So in this case the carry flag would be set to logic 1 level. Now we know that, okay, but there could be some other cases where the program could be a little more complex and we have no notion as to what kind of data byte could be transferred into the 8085 if we just writing interfacing programs. So over there, use of the respective jump instruction, conditional jump instructions, are very, very important. You need to keep a track of what would happen and what would not, okay. So this is just an example over here that I wanted you all to consider, so that you might have a little bit of idea as to where things would go from here on. Okay, now next up we got the JZ and the JNZ instructions. Okay, now JZ instruction is also such a kind of conditional jump instruction, which stands for jump on 0. Okay, so for the JZ instruction, it is very important that the 0 flag be equal to logic 1 if it's to be executed. Okay, so in a way we can say that the JZ instruction would be executed only if the 0 flag bit is set to the logic 1 level. Okay, only then the program control would transfer to the specified 16-bit memory address serving as its operand. And on the other hand, the JNZ instruction, the condition is just the reverse. Okay, now JNZ instruction would basically stands for jump on no 0, okay, which means that the JNZ instruction would be executed only if the 0 flag bit is reset or set to the logic 0 level. Okay, and only then the program control would transfer to the specified 16-bit memory location serving as its operand. Now, as an example for the jump on 0 and the jump on no 0 instructions, I just thought of showing this particular programming code over here. So you can see that we have just written about 3 lines of code over here where we're loading the register C with the data byte FFH. Okay, and then we're constantly decrementing the value of the register C. Okay, and each time the value is decremented, okay, the conditional jump statement, that is JZ, that is jump on 0, it just checks whether the content of the register, whether the register C's content is basically equal to 00H or not. So this is what it is supposed to come down to. So the content of the register C is just decremented step by step, okay, once each time, so that it just finally comes down to the value 00H, okay. And this particular decrementing process of the register C's content will just continue to go on as long as it's not equal to 00H. Now whenever it is equal to 00H, at that very moment the jump instruction, okay, monitors this condition and resends the programming control to the location XX10H, where the register C is once again being loaded with the memory location XX10, where the MVIC command is present, where the C register is again loaded with the data byte FFH. Okay, so there's a little bit of a little line of code, okay, that I've just missed out here that I should put over here. Okay, so I'll just select this particular line, okay, and then paste it somewhere else. Okay, so this is where I just gave it. Okay, and I'm gonna write here the particular code that I just missed. So if I write here again, let's say JNZ, okay, to XX, what can I say? XX12H. So this is XX12H. Okay, so where the DCRC command is present. So you can see over here that once the FFH data byte is loaded into the register C, okay, and then you just decrement its content once, and then it just comes down to check whether the content of register C is 0 or not. So whenever it's not 0, the control is sent to the memory location XX12H. So it just keeps on decrementing this time, until the content of the register C is 00H. Now once the content of the register C is 00H, okay, the jump on no zero instruction, its condition fails. So the program control will just transfers through to the immediate next memory location, where the JZ instruction, that's the jump on zero instruction, is present. And as soon as this particular instruction is encountered, the program control is transferred to the location XX10H, where the C is again loaded with FFH data byte. Okay, and this just keeps on going something like this. So this was just a example which would just give you an idea as to how these instructions could be used. So this kind of a particular program code snippet that I've just included here is often very useful in writing counter type of programs. Okay. Now similarly, there are other conditional jump instructions such as JP, JM. Okay, so that just stands for the jump on positive and jump on minus respectively, and that work on whether the sign bit is equal to 0 or 1 respectively. Okay, so the JP instruction gets executed if the sign bit is equal to 0, while the JM instruction gets executed only if the sign bit is equal to 1. Okay, so only then the program controls get transferred to the specified 16-bit memory addresses, only on the satisfaction of the respective conditions for each of these instructions, JP and JM. Okay, similarly we have the other two instructions as well, that is jump on even parity, that is JPE, and jump on odd parity, that is JPO. For these instructions, the parity bit is monitored. Okay, so if the parity bit is equal to 1, the JPE instruction gets executed, and if the parity bit is equal to 0, the JPO instruction gets executed, and the program controls are transferred to the respective 16-bit memory addresses. So you can write any type of program, and what exactly your program does, if it just monitors some flag bits, like for example the sign flag, the parity flag, or the 0 and the carry flag. So all these could be just monitored by the using all these jump instructions, conditional jump instructions, and that way you could just write your programming code depending upon how you want your program to behave, depending upon which of the flag bits you're actually inspecting, and that way you could just design the program as per your need. Okay. Now it's to be mentioned that for all the conditional jump instructions, okay, the 8085 will actually executes them, or rather consumes a time period of 10 t states, okay, or rather 10 clock periods if the condition holds true. So if the condition is true, so you have all these jump instructions over here. So for each of them, whenever the condition is found to be true, then the 8085 will execute them over 10 clock periods, and if the condition is false, then it is executed for 7 clock periods. So 7 clock periods is the time consumed for executing a jump instruction if its respective condition holds false. Okay, so I'm just gonna write it down over here. There you go. So for all the jump instructions, these conditions basically hold. Okay, and while executing the jump instructions, always to be kept in mind for all the conditional as well as the unconditional jump instructions, the flag bits remain unaffected. Okay, the jump instruction do not affect the flag bits whatsoever. Okay, so that said, we just come to the end of this tutorial, and we're going to be catching up with you all next in the forthcoming one. So till then, just keep watching, and we'll just meet you shortly. Okay, so till then, just bye bye.